negative leading coefficient. Based off of those videos that you watched on YouTube yesterday, those 3 short videos that were not me, those are the same things that I'm covering here in this first couple of minutes. All right, so here I've got a constant graph. So f of x equals some constant. Let's say that constant is 2. So what that gives me is I have a straight linear graph that's it is horizontal, and it's at positive 2. Well, what if I said f of x equals a negative constant? Okay, in this case, maybe it's negative 2. That same value is still a horizontal graph. Okay. Now, this is where it gets important. When we start talking about our exponents being greater than 0, or our degrees being greater than 0. So for this one, f of x equals x. And remember, our degree is an understood 1. So when we have a degree of 1, okay, that is going to be something that is linear. So like x, if we have y equals mx plus b, that is linear. And the highest degree on that one, let me go ahead and write that down here. If we had y equals mx plus b, okay, that would be linear, and our exponent is 1. So when we have a degree of 1, both ends of the graph will point opposite directions. Okay. When we have an exponent with a positive degree, so here's 2, then both ends of the graph will point in the same direction. All right, so what I want to do is I want to go through and find the examples that I have that are odd, and let's see if they all point the same direction or if they all point opposite directions. So f of x equals x to the first. These pointed in opposite directions. X to the second is an even degree, so I don't want to look at that one. F of x to the third, this is cubic, that is an odd degree, and the ends point in the opposite direction. Okay. X to the fourth is an even degree. X to the fifth is an odd degree. In that case, the directions of this parent function would point in opposite directions. Now, that is the same thing even if it was a negative x, okay? But the difference between a positive and a negative, let's look at x to the first. X to the first power, this was an increasing graph. Okay. When it is negative, it is a decreasing graph. Okay. So again, the only thing that I'm really looking at here, though, is I want to see if when I have something that is to the first power, do the ends still point in opposite directions? Regardless, whether it is a leading coefficient of a positive value or a negative value, I just want to see if the ends point in opposite directions. So I have a degree of 1, which is an odd number, and they still point in odd directions. Okay. Negative x squared, that's an even degree. Negative x to the third, that's an odd degree, and both ends point in opposite directions. Negative x to the fourth, that's an even degree. Negative x to the fifth, that's an odd degree, and both ends of the graph point in opposite directions. Okay, so now that we've looked at the odd degrees and the opposite directions that they point to, let's go back and look at the even degrees. Right? So if the odd degrees point in opposite directions, then the even degrees are expected to point in the same direction. So x squared has an even degree. Both ends of this graph point up. When it is negative x squared, instead of pointing up, both ends are going to point down. Again, because it's an even degree, both ends point the same direction. Our next one is going to be x to the fourth, so it's going to be quartic. So if I have x to the fourth, it's an even degree, and it's positive because it's a positive leading coefficient, then these will both point in the same direction, and it happens to be up. The reason that it's up is because the coefficient is positive. The degree of 4 does not have to do with which direction they're pointing up or down. The degree of 4 just tells me they're both going to be pointing in the same direction. Okay. So negative x to the fourth, again, an even degree, means that they're both going to be pointing in the same direction Because it's a negative, means that the direction is going to be pointing downwards or decreasing. Okay. Now I'm going to erase this bottom one here for a second, and I'm going to draw or just assume a couple of different equations here. So let me erase this stuff here. And let's come up with some other graphs and see if we can kind of just determine the end behavior. Okay. All right, so what if I had negative 4x to the 72nd power? Okay, if it's negative, that tells me that my graph is going to end up on the right side pointing down because it is negative. So it is going to be ultimately be a decreasing graph. Okay. So the right side of the graph is going to be negative. I think I said left side. So the right side of that graph is going to be pointing down because this is a negative leading coefficient. The degree is a positive number, which means that both ends are going to point the same direction. Okay. The stuff that takes place in the middle of the graph, there's a lot going on in here. Actually, there's 71 turning points. Something, if I could just draw it, that we will be talking about. Okay. But what I want you to see is that if it's an even degree, both ends are going to point in the same direction. Okay. And because it's a negative leading coefficient, that direction just happens to be down. Now, what if I said negative 3x to the 27th power? Okay. The leading coefficient is a negative, which means the right side of our graph is going to be negative because that's the ending side of our graph. It's going to be negative. And then the degree is an odd degree, which means that the ends are going to point opposite directions. Okay. Since 27 is an odd